Hi everyone. So here we are with the next lecture of matrices. I have picked up few particular questions. These two questions belong to exercise 9th A and this belongs to 9th B. So in today's lecture we'll solve these three questions, and importantly we'll learn something called as matrix multiplication, which is really important. I suggest you listen that part very carefully. Anyway, so we're going to start with this one. To understand these, first you got to understand some basics. So let's begin with them. If I have a matrix anything like this, 1, 2, 3, 4, you know that all of these are called as elements, correct? Now can I say this element 1 has a particular position? It is not here, but it is here. So it is at a particular position. That particular position can be numbered. For example, each of the element I'll represent by the small letter A. Listen carefully. In matrices, each of the element can be represented using a small letter A. But the position that it carries, for example, this 1 carries a position that it belongs to first row and first column. Nobody else has that position, only this has. So that can be written like this: element A at position 1, 1. Note it that 1, 1 are subscript. That means they are written in a small font and below the letter A. Okay, so this first one indicates the row number and the second one indicates the column number. So when I say A11, you should understand I'm talking about element at this position, which is nothing else but 1. So let's think about the number 3. This number 3, element 3, is at which position? So if I want to denote that, I'll say A, that means the element, and the position I would write, you tell me it belongs to which row? Second row. So 2. Which column? The first column. So 2, 1. A21 means this. Similarly, if I go for this number, I would call it as A. Now this belongs to first row, second column. Check it out. This is column 1, column 2. And this entire is row 1 and this entire is row 2. So now this element 2 is in row 1, column 2. So I would say 1, 2. Because always the row has to be written first, column later. And the last thing, obviously this 4 is at second row, second column, A22. Did you understand this? If not, pause the video, go on again back and understand this part. And we will proceed now. So every element can be denoted using the letter A and by the proper position. And while writing the position, first number should be the row number, second number should be the column number. Alright? Now, if you understood this, then you can now understand with me the first question of this lecture. It says, construct a 2 cross 3 or 2 by 3 matrix. That means we have to make a matrix. We have to put the elements whose elements A, I, J. Here I is the column number, J is the row number. But he has not specified the value like 2, 3, 1, 2, 1, 1, 3, 1, nothing like that. So that means he is saying any random element here. So whose elements Aij, that means all the elements, all the random elements that we'll talk about in that matrix are given by this equation. That means any element you're talking about, any random, will be given by this formula, which is 3i minus j. Okay, not so pretty clear, no issues. Let's start it to understand. First of all, he says construct a 2 by 3 matrix. So I'll at least make a rough 2 by 3 matrix ka outline. Okay. So if I do that, two by 3 means 2 rows. So 1, 2 and 3 columns. 1, 2, 3. Alright, here it is 2 cross 3. So this is row 1, row 2. I'm writing it lightly. And this is column 1, column 2, column 3. Alright, so how many elements, by the way, total in my matrix? 2 into 3, that is 6. So 1, 2, 3, 4, 5, 6. I have to construct this matrix. That means I have to fill these elements as per given condition. And that condition, again, we will see, where Aij equals to 3i minus j. I'll write it here. Any random element, Aij, equals to 3i minus j. Okay. Let's break this down. Say, for example, I want to fill this element. This is which element? This is element A11. So I will write A11 will be equal to, as per this formula, this given condition, can I say A means row number, J means column number. So I'll say 3i is given here. What is my I ka value here? 1. So 3i, yani 3 into 1, minus as it is. J means the second or the column number. What is my column number here? 1. So 1. So if I solve this, it is 3 minus 1, which is 2. So my first element is 2. Let's take one more example. Say, for example, I want to fill this element. What is the position? Row number first, column number second. So that means A, 1, 2 I am calculating now. As per the formula again, so 3i minus j. So 3 into, what is I ka value in this case? 1 again. Minus, what is j ka value? It is 2. So it is 2. So 3 minus 2, which becomes 1. Let's randomly pick one more. Say, for example, I'm talking about this. So tell me the position. Can I say it is second row, second column? 2, 2. Let's put the values as per the formula or the condition. So I would say it is nothing else but 3 into I here is 2 minus j here is 2. That becomes 6 minus 2. Answer is 4. So this is 4 and so on. If it is done, all the elements are done. I have to show these calculations. By the way, it's important. Acha. So once it is done, the elements are done, my matrix is constructed. And that's what my question demanded. Check it out. Similarly, we have one more question. Question 4. I have to construct this time a 3 by 2 matrix. Matrix looks something like this, 3 by 2 he says, for which, again a condition or a formula, for which any random element if you want to find, that will be given by I into j. Let's carry this out. First of all, pay attention. Matrix has to be 3 by 2. Chalo banate hain. 3 rows, 2 columns. 1, 2, 3. 3 rows, 2 columns. 1, 2, 3. That's it. 3 by 2. And the formula or the condition given is Aij equals to I into j. Let's start the first position. What position do you think it is? If you want, you can write R1, R2, R3, C1, C2. So A11 obviously. as per the condition. I into j means 1 into 1. Answer is 1. So my answer here is 1. Let's take one more. What position do you find here? First row, second column. So that means it is A12, which is equal to I into j, 1 into 2. Answer is 2. And so on. Can I say now it has become understandable? Everybody? Alright, I hope so. Time to go for 9th B ka question 14th. It says find matrices A and B, okay, such that A plus B is given by this matrix and A minus B matrix is this matrix. Okay. Does it sound like simultaneous equation solving? Yes, and that's correct. So if I have two variables and two equations, how do I solve them? Can I say very simple method? Add equation 1 and 2. So can I say plus b minus b will get cancelled? Yes or no? Chalo, let's do it and see. So a plus b is given by 5, 4, 7, 3. A plus b is given by 5, 4, 7, 3. A minus b, let's check out, is given by what? It is 11, 2, minus 1, 7. So 11, 2, minus 1, 7. And just one thing. I am not writing the order, but you need to. In every matrix that you write, even if the question doesn't ask, you got to write the order every time. Alright. Now, here is my first equation. Let me call it as equation 1, equation 2. I'll say adding equation 1 and 2. With that, I'll get LHS आपस में add होगा, RHS आपस में, which becomes A plus B plus A minus B equals to 5, 4, 7, 3 plus 11, 2, minus 1, 7. Here, what do I get? A plus A, 2A. B is gone. So 2A equals to. Next question. Pay attention. Can I say this is like addition of two matrices? Is that possible? Yes, because the order is same. And while you add corresponding elements आपस में, so that becomes 5 plus 11, 16, 4 plus 2, 6, 7 minus 1, 6, 3 plus 7, 10. So 2A ka answer is this, which means my A ka answer is 2 goes that side. It becomes 1 upon 2, 16, 6, 6, 10. Clear? Now pay attention, scalar multiplication. So when you have something to be multiplied, it needs to be multiplied with all the elements. Huh? So my result of A comes to be 8, 3, 3, 5. I'm done with the answer of A. Once I got the A matrix, I'll substitute this value in any of the equations. For example, this or this, and I get the answer of the matrix B. I hope it's clear. Nice. So now it's time for that we understand matrix multiplication. But well, the time that I see is already almost 15 minutes. So let's not make it too long. Matrix multiplication itself requires some time. So we will do that in the next lecture. See you very soon. Thank you everyone.